it's okay. Uh, uh, we are through this eight, I think. Now we'll start with the reflection. So, good morning, all of you.
Good morning, ma'am.
Good morning, ma'am.
Good morning, Beta. So, please start with the reflection. Yes, Beta. Start reading,
Reflection.
Beta.
Reflection. Most objects we see reflect light rather than emit their own light.
So, what are we seeing? That most objects, what does that mean, Beta? That most objects that we observe, that we see, what are they doing? They are reflecting. They are reflecting. And they are not emitting the light. What does that emission means? Like if I see a bulb emits light. If I see a tube lamp, it emits light. Isn't it better? The candle, it gives out light. Emits
Yes.
means giving out light. But what are desk, table, chair, the blackboard, the fan? Are they emitting their light? Are they
No.
emitting their light? No. So what are they doing? They are reflecting the light so that we can observe. So reflection is a must for observation of a visualization of an object. You agree? You agree, beta?
Yes.
Okay. What is this? What can you see?
Reflection.
Reflection of a mountain, isn't that, in the forest? Can you see this? Beautiful. This is the object. So this is the object and this is the image. Yes or no, beta? Isn't it?
Yes.
Beautiful. Same thing you can see over here. How beautiful it looks. See, look at this. You can see the line that I'm putting?
Yes.
Yes. So this is the object and this is the image. Yes. Agree, beta? So it's a beautiful,
Yes.
yeah, beautiful duck which is floating on the water, swimming on the water. This is how you can see the reflection. Now we'll talk about lateral inversion. I just want to tell you one thing that you look yourself in the mirror, isn't it? Do you look yourself in the mirror or not, beta?
Yes.
Yes.
You do look yourself. Now, if I ask you, raise your hand, raise your right hand. What you will observe in the image? Will it be right hand or left hand?
Left.
Left hand. Now this, yeah. Now this is what? This is lateral inversion. That means if you raise your right hand, left hand shows. If you raise your left hand, right hand shows. This mechanism, this phenomena is known as lateral inversion. Is it clear,
Yes.
children? Eighth standard, is it
Yes.
clear, beta?
Yes, ma'am.
Read, beta.
Lateral inversion. For example, you are the object and what you see in the mirror is your image. You are
Okay.
identical to your image as seen in the mirror. In case of a plane mirror, the image formed is erect and same size as the object, but there is one difference in your left and right. When you move your right hand, the image it seems as ma'am, screen.
As you cannot see,
Ma'am, yes.
yes, the image is seen now.
Images seems as if your left hand is moving. This is called lateral inversion, where left appears to be right and right appears to be left.
Okay. Now, can any of you explain? I just taught you the summary. I just gave the gist of what exactly is lateral inversion. Can any of you explain?
Yes, ma'am.
Yes, tell me, beta. Can you explain, beta?
Ma'am, if we stand, ma'am, if we in mirror, if we raise our right hand, then it in mirror we can see it's our left hand.
Exactly. So left becomes right and right becomes left.
Left.
Right? Any problem? Now look over here. Right? This is the right hand. Yes or no, beta? So this
Yes.
becomes the left hand in the image. Any problem, beta? To understand? Did you understand or not?
Yes.
Yes.
All of you? All 10 of you, beta? Girls,
Yes, ma'am.
all of you understood, beta?
Yes.
Okay.
Yes, ma'am.
Okay, beta. Now the same thing. Can you see the letters? So there is a lateral inversion of letters. See, if anything is written on your uh, T-shirt, when you look yourself in the mirror, you can do these activities at home, beta. Write on A, B,
Yes.
C, D till Z and put it in the front of the mirror and see the image. The reflected image, it will be somewhat like this. Got it?
Yes.
What is written, by the way? Can you read it?
Physics.
Physics.
Exactly, it is physics. Very good. See how it looks like, isn't it? It looks so weird.
Yes.
Fine. So this is also called as lateral inversion of image, isn't it?
Yes.
Now let's see when light strikes an object. Please read better.
Light
When
travels
light.
in a
Who wants to read?
Ma'am, Hamidani Khadija.
Okay, Hamidani Khadija, start better.
light travels in a straight line. It will continue moving in a straight line unit it hits something. Depending on what it hits, light may behave in very different
Ways. So we know that light travels in a straight line. Yes? For example,
Yes.
now if this is the eye, you are looking, right? You are looking. And here is the candle. Okay? So if you're taking a straight rod, you can see. So it travels in a straight line. Now if I make the rod like this, will you be able to see the candle better?
No.
No. So it shows that light travels in a straight line. All of you agree?
Yes.
Yes.
And first
That's the
also
first thing.
you're right.
Exactly. Now the light is traveling in a straight line. Now if I put something over here, do you think it will travel in the straight line? It will get reflected, isn't it better?
Yes.
So if there's an obstruction, if it hits something, it gets reflected. This also you agree? This also you agree better?
What, ma'am?
If
Yes.
the light is having any obstruction, then it gets reflected. Didn't I teach you?
Yes.
Yes. So if it is hit by something, then will it continue in a straight line? No, it will be reflected, isn't it?
Yes.
Are you understanding what I'm saying?
Yes, ma'am.
Okay. Now, last one is, now what hits? Light can behave in different manner. For example, if it is hit by a solid, hello, maybe glass, then the rays come here and then it get diverted, then or it get reflected. It can do anything. So depending on what it is hitting, the light will behave differently. Do you understand?
Yes.
I will do one by one. Then I will teach you. One point, then I will teach you better. Start with it.
Light rays travels in straight lines from the light source.
Look over here. This is light source. This was light source.
Yes.
Hello.
Yes.
Yes.
yes, ma'am.
It is traveling in a straight line. Traveling
Yes.
in a straight line. Yes, it is see
Yes.
moving to a straight line. Okay. Second point, beta.
When it hits an opaque object, some light is absorbed and the rest reflects off.
What is the meaning of opaque object? Please explain. What is the meaning of opaque object? Girls, I taught you in 7th standard, beta. What is the meaning of
Yes,
opaque
ma'am.
object? What is the meaning of
Like,
opaque object? Light? Tell me. What is the difference between opaque, translucent, and transparent? You know everything.
tra- transparent, we can see properly object, and translucent, we can see like blur and it is not proper. And in
Okay,
opaque, the object cannot see.
very good. That means the light is the light is passing through transparent. The light is passing through, but not very much translucent. Light is not at all passing through is opaque. You agree? You
Yes.
agree? Okay. Now, what is transparent? That is glass. Simple. Glass is transparent. You agree or not? We can see through.
Yes.
Yes. What is translucent? You can see some sort of tinted glass, white glass, smoky glass. Have you observed smoky glass? Like you can see who is on the other side, but you cannot make out who is it. There's someone. There's someone, but who is it we won't know. That is translucent. And in opaque, we cannot see. Any problem?
No, ma'am.
You understood, okay. Now what they are saying, that when the light is hitting an opaque object, some light is absorbed. See here. Now it is coming, for example, I take this as an opaque object, right? Some is absorbed and some gets reflected. When it is getting reflected, where it is coming? To the eye. Yes or no? Hello?
Yes.
Where is this reflected ray going? It is going to the eye. Isn't it better? Then only I can see the object. What do you say?
Yes.
What do you say? Agree?
Yes.
Yes.
Now we come to the transparent. Wait.
If the object is transparent, light rays pass through it easily.
Yeah. For example, if this is transparent, then all the rays will pass through like this. All the rays will pass through. You agree? And we can see. You agree or not? In transparent. The light rays will pass
Yes.
through. Okay. Now we come to translucent. What is written with a
If the object is translucent, some light can pass through, but the rest, none, but
rest
the
of the light?
rest
Rest of
of
the
the
light?
light will be reflected.
Okay. Now let's say translucent. That means some light can pass through and some light will be reflected. You understand? Hello? So when it is
Yes.
passing through, that means it's absorbing. When it's passing through, so some light can pass through, rest of the light is reflected. It is not absorbed. Remember that. In translucent. When it's an opaque object, the light is absorbed. That's why we cannot see and the rest reflects off. So more light is absorbed in opaque object. In translucent, light is passing through and rest is reflected, and in transparent, all the lights are passing through. Did you get the difference? Let's start with transparent. Let's start with transparent. Light rays pass through. All the light rays pass through. You agree?
Yes.
That is transparent. All the light rays are passing through. Then we come to translucent. Some are passing through, rest are reflected. Agree?
Yes.
Yes.
Yes, ma'am.
Opaque. Opaque. Absorption comes. Some light is observed, rest reflected. Understood or not? You got the difference between transparent, translucent, and opaque? Yes? Transparent, all lights are passing through. Translucent, some are passing through, rest are reflected. Opaque, some absorbed, rest reflected. That is the difference. Did you understand?
Yes, ma'am.
Yes.
We see reflection applied by a flat mirror. Please read it.
Reflection of light by a flat mirror. Light reflects sy- symmi- symmetrically so
Symmetrical.
that the symmetrically so that the incident light angle is equal to reflect light angle.
What is the first law by a flat mirror? That light is reflecting equally. What is the meaning of symmetrically, beta? Equally. So that angle of incidence becomes angle of reflection. Look over here. This is the mirror. What is this, beta? This is the mirror. Agree?
Mirror.
This is the mirror, right? Okay? Fine. Now, this beam is coming on the mirror. What is this called as? Incident ray. What is this called as?
Incident
Incident
ray.
ray.
It gets reflected. What it becomes? Reflected ray. Agree?
Yes.
In the center, I
Yes.
will make a normal. What I will make, beta?
Normal.
Normal, which is making 90 degree. Isn't it, beta? That's what is called as normal. Any problem?
No.
So the incident ray and the normal makes angle of incidence. So this becomes angle of incidence. The reflected ray and the normal makes angle of reflection. Is it clear? What we find? Angle I is equal to angle R. You understood?
Yes.
All of you? Girls who are present, are you understanding?
Yes,
Yes,
ma'am.
ma'am.
Okay. So this is the first law of reflection. Okay? Same thing with the second law. Please read with it.
The laws of reflection. The angle of incidence equals the angle of reflection. The incident ray, the reflected ray, and the normal are all in the same plane.
So the first law that we understood just now was angle I is equal to angle R. Agree?
Yes.
Yes. The second law is see. This is the plane mirror. Now see. This is the mirror beta.
Yes.
Yes. The incident ray, this ray. The reflected ray, this ray. And the normal all lie in the same plane. Agree?
Yes.
That's it, the second law. So what are the two laws? First is angle I is equal to angle R. And second, incident ray, reflected ray, and the normal lie on the same plane. Any problem? Any problem?
No.
All of you understood better? So tell me what are
Yes.
the laws of reflection?
Angle I is equal to angle R.
Okay, second, that's the first you said. What of the second? The second law of reflection. Hello?
Ma'am,
Yes? Say? What
ma'am,
happened?
sorry, but I didn't understand.
But you said that you understood.
No,
I
I
told you
have
so many times that if you're not understanding, why you keep on saying yes, beta? What did I say? The incident ray, the reflected ray, and the normal all lie in the same plane. This is the same plane. I hope you know what is plane on the same
yes,
surface. So
yes,
they lie in the same plane. There's the second law. Now you can speak. Yes. Hello.
yes,
Now
yes,
can
ma'am.
you say now? Okay. Say better. What are the laws of reflection? Hello.
Yes, ma'am.
Yeah, tell me what are the laws of reflection? I just taught you. Speak up.
Means
Yes. Can anyone? Jalisha,
yes, ma'am.
explain. Hello.
Means the
Explain.
yeah,
What happened?
the angle of incidence
Then
means
Is equal
relate
to is equal to
angle of reflection.
exactly. So angle I is equal to angle R. That's the first law. Second law,
Incident ray and reflected ray.
re-
and
normal,
normal all lie on
And
the
normal.
yes,
same
and all lie
plane,
on the
Mirror.
same
same
plane.
plane.
Exactly. All of you
Same.
understood?
Yes.
Yes.
Yes, ma'am.
Yes. All of you understood now?
Yes.
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 Okay, fine. Okay, now read this. The same thing but in a different manner. Yes, better. Read.
The law
The
of reflection. The law of reflection states that the angle of incidence equals the angle of reflection. Light rays reflect from a mirror at the same angle at which um,
Yes.
screen
Just a moment. At which they
at
arrive.
which
They
at which
arrive.
they arrive.
Okay, fine. So what we see over here, can you see over here, beta? This is the mirror. What is this? This is the mirror,
Mirror,
isn't it? What is
mirror.
this ray? Now you have to tell me, what is this ray, beta?
incident ray,
Incident rays. What is incident ray? What is this ray?
reflected ray,
Reflection
Very
ray.
good. Reflected ray. All of you understand now? What if I
Yes.
place
yes,
something over here like this? What it will become, beta?
normal
Normal.
Very good.
Normal.
It's
line,
what? Normal line. Very good, very good. Now what is this angle, beta?
Yes,
What is
ma'am.
Incident.
this angle?
incident
What
angle,
is this angle? Very good. Incident angle.
incident
And
angle,
what is this angle, beta?
Reflection angle.
Reflection.
Reflected angle. So what is the formula? Angle I is
angle
equal
I
to
is equal
To
to
angle
angle
R.
R.
R. Very good. That's the first law we know. We have come to know the first law of reflection. Very good. Now look over here. If I take this as 30 degree, obviously this one will be also 30 degree, isn't it?
30 degree.
Now what is the second law
Yes.
of reflection, beta? Incident ray, reflected ray,
Reflected
and the
ray
normal
and normal
lie
are on
lie
the same
in the
plane.
same plane. That is the second law of reflection. Now tell me any problem.
No, ma'am.
No, ma'am.
You have learnt the two laws of reflection, all of you. I have taken 3, 4 slides for the same thing. I think you have understood why I have done so. So have you
Yes.
learnt by heart now the two laws of reflection? All of you, beta?
Yes,
Yes, ma'am.
Again the same thing, but again you will learn something more to it. Please read better.
Reflection.
Reflection. Reflection is when light changes direction by bouncing off a surface. When light is reflected off a mirror, it hits the mirror at the same angle.
Hits, not heats. It hits.
It hits the mirror at the same angle, that is the incidence angle I,
Theta. Theta, theta I. What you will say? Theta I.
theta I.
So this is how I
Theta
straighten.
I.
Just a moment, just a moment.
Okay.
THETA. It's a mathematical notation. When you will grow up, when you will go in 10th standard, you will come across all this notation. Okay? So that
Okay,
time it
ma'am.
will be easy for you. So this is called as theta.
Theta.
Then
Theta
theta
I,
I.
as it reflects off the mirror, the reflection angle theta R.
Understood?
Yes.
Then
The, the normal is an imaginary line which lies at right angles to the mirror where the ray hits it.
okay, any problem? What is something new to it? What are they trying to show? What are they trying to tell us? Can you tell me better? Hello. Hello.
M-
What are you trying to tell us?
Ma'am,
You tell me. Whatever you understood, you tell me. Hello. Can you hear me?
ma'am, when
Yes. Can anyone explain? Can any of you explain
Mm,
better?
okay, ma'am. Can I?
Yeah, sure.
Ma'am, like reflection is when that light changes direction by bouncing the uh, surface.
You're not supposed to read. What you learned from this figure, you tell me that. It's the same thing. It's the fifth slide I think I'm using for the reflection. Don't you say?
Yes.
So you use your own words, please, for the explanation. What is happening? Where is the incident ray over here?
This
This
one.
side. It
Yes.
bounces off. When it bounces off, it becomes.
Reflected ray.
All of you understood? Hello? So incident ray hits the mirror and then bounces off. It becomes reflected ray. Any problem?
No, ma'am.
We are drawing an imaginary line that is called as normal. Yes or no? Which lies at the right angles to the mirror. So which lies at the right angles to the mirror. You agree? It's making 90 degree. Right? Hello? And the incident angle theta 1. Now this is theta 1 will become theta r.
R.
So incident angle will become reflected angle by due to normal. Yes or no?
Yes.
That's all. There's nothing else. The same thing, but what is the new inclusion over here? Theta I and theta r. Nothing else. We have used theta I and theta r, but everything remains the same. Tell me
Yes.
whether there's any problem or not.
No, ma'am.
So I thought you will explain to me. Again, laws of reflection. See, so many slides I've taken for the same thing, but this is very, very important. This will stay with you throughout your life if you're taking science stream. You know that?
Yes.
I'm trying to make things very clear right now. Yes. Now we read laws of reflection. Please start with incident ray.
Laws of reflection. Incident ray. The light ray falling on any surface is called the incident ray.
So
Reflected
this
ray.
is just a moment. Just one by one we will do. Now what is incident ray? Light falling on the, tell me, on any surface. So this is a surface, isn't it? So light is falling on this surface. So this becomes incident ray. All of you agree?
Yes.
Only one yes?
Yes.
Only two? What about the rest of you? Hello?
No, no one is giving
No one
answer
is
on this.
answering.
Yes, ma'am.
Now we come to reflected ray. Please.
Reflected ray. The light ray that comes back after reflection is called the reflected ray.
Let's see. After reflection. This is reflected ray. Agree? Agree or not?
Yes.
The incident ray after hitting the plane mirror reflects. It bounces back and it becomes reflected ray. Agree all of you?
Yes.
Now we'll do
Yes.
the normal ray. Please do the normal ray.
Normal ray. The line perpendicular to the reflecting surface is called the normal ray.
This is perpendicular. What does the perpendicular word means, beta? It makes 90 degrees. So this is perpendicular. You see this red line? It's
Yes.
perpendicular to the surface. This is making 90 degree. This is also perpendicular. This is also making 90 degree. Agree?
Yes.
So this normal line is making 90 degree to the mirror surface. Is it clear, beta?
Yes.
That becomes normal. Now we come to angle of incidence. Please.
Angle of incidence. The angle between the incident ray and the normal ray is called the angle of incidence. Angle
Okay,
of
okay.
reflect.
Just a moment, just a moment. Angle between the incident ray and the normal. This one. It is called as angle of incidence. Yes or no? I. Agree?
Yes.
Angle I is the angle of incidence. Agree with all of you? Yes?
Yes.
Yes.
Now angle of reflection. Please see.
Angle of reflection. The angle between the reflected ray and the normal ray is called the angle of reflection.
Angle between the normal and the reflected ray is called as angle of reflection. That is angle R. Agree?
Yes.
Girls, do you agree?
Yes,
Yes.
miss.
Fine. We talk about smooth and highly polished surface. Wait.
Smooth and highly polished surface. What happens when light falls on a mirror?
Now this is a smooth surface. Can you see this better? Hello, girls.
Yes.
Can you see this? This is a mirror, right? This is a mirror better. Okay. Now this is a torch. The incident ray is falling. It gets reflected. This ray is falling. This gets reflected. This is falling. This gets reflected. Now it is uniform. Can you see the uniformity? Hello. These arrows says that it is incident. These arrows says that it is reflected. You agree? Hello. Do you agree? Girls,
Yes, ma'am.
do you agree or not?
Yes, ma'am.
And the reflection is uniform. That also you agree, girls?
Yes.
See, now they are playing. One is holding the torch. So what is this ray called as, beta?
Incident ray.
Incident. And she is holding a mirror. That's a glass, right? Or a surface, smooth surface. You agree? Smooth surface?
Yes.
Surface. Agree? This ray is what?
Reflected ray.
Reflected ray. And you can see a spot over here. Can you see this?
Yes.
Any problem? Any problem,
No.
beta?
No, ma'am.
Now you understood what is happening? Incident ray, reflected ray, image. You know now how it is happening.
Yes.
Now we'll talk about two types of reflection. One is uniform and other one is non-uniform. Just now we talked about which type, beta, uniform or non-uniform? Just now?
Uniform.
Uniform, exactly. Now we are going to learn about non-uniform as well. Please read.
Clear versus diffuse reflection. Smooth, shiny surfaces have a clear reflection. Rough, dull surfaces have a diffuse reflection.
That's it. What are they saying? That is a smooth, shiny surface. Can you see the smooth, shiny surface, beta? This is smooth, shiny surface. Okay? This is incident. The red one is all incident, and the blue one is all reflected. This gives you a clear reflection. What it gives, beta? Clear reflection. Whereas, you see over here, it is uneven. Can you see this? Uneven. So the incident ray is falling parallel, but the reflected ray is going here, one is going there, not uniform but non-uniform. So this gives you a dull reflection. You understood? Can you see the difference, beta? Hello? Can you see the difference?
Yes.
Yes. So this is what? Diffuse reflection. What it is, beta? Non-uniform or diffuse reflection. Okay? So what is happening? Light is scattered different direction. Can you see this? One is going here, one is going there. See? Or crisscross. It is haphazard. It is non-uniform. And we get a diffuse reflection. Any problem? So we came to know about two types of reflection. One is, tell me, uniform. The other one is non-uniform. One is
Non-uniform.
clear and second one is diffuse. Any problem?
Diffuse. No.
So I've given you two words, uniform, non-uniform, clear and diffused. Okay? Okay, beta?
Yes.
Yes.
Same thing. Let's see what is irregular. Can you, first of all, would you be able to read it? Otherwise, I will do it.
Yes. Yes, ma'am.
Will you able to read?
Yes.
Okay, read, ma'am.
The laws of reflection are valid for reflection from all shiny surfaces. Thus, the angle of
Has
incidence
to be.
has to be equal to the angle of reflection in each case. It is just that the rays reflected from an irregular surface reflects from
Are, are
unparalleled
parallel
rays.
rays.
Yes, sorry. Ma'am, it's
When the rays,
again and again being blur.
okay. Now, when the
Yes.
rays, can you read or
When the
not?
rays
See, now I've made it big.
re-
Reflected
and the rays
from
being
a plane
reflected,
surface are not parallel,
the reflection is known
when the
as
rays reflected from a plane surface are not parallel, the reflection is known as irregular reflection. Understood? Understood, beta?
Yes.
What is happening? See, all the lines are parallel over here. See, can you see this? All the lines parallel. See, the lines which are coming is all parallel. Yes or no?